Hi, Mr. Richards here. Today's lesson is on solving quadratic equations by using the quadratic formula. Our key concept box on the quadratic formula tells us a lot of the things we need to know. The solutions of a quadratic equation in the standard form of ax squared plus bx plus c equals 0, where a is not equal to 0, are given by the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. This is something you need to have memorized. This is something you need to know. So when we go to solve the equation using the quadratic formula, we first need to get this into standard form, that ax squared plus bx plus c equals 0. And this does not equal 0 yet. And so I'm going to rewrite this equation over here, x squared minus 2x equals 35. We need to get this right side to equal 0, so we'll start off by subtracting 35 from both sides, so that this cancels out, and we are left with x squared minus 2x minus 35 equals 0. Now the next thing that I like to do is to define what's my a, what's my b, what's my c. Well, my a is here with the x squared, and there's no coefficient here. It doesn't mean it's a 0, it means it's a 1. So my a is equal to 1. My b is right here at negative 2, so b equals negative 2. And lastly, my c is here at negative 35. So now that we have the equation into standard form and have defined our a, our b, and our c, we can now substitute this into the quadratic formula. So I would start by writing down the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c. And that's going to be divided by 2 times a. And now we need to make our substitutions in. X is going to equal, well, the negative b, the negative of negative 2, is just a positive 2. So we can write in a 2 plus or minus the square root of negative 2 squared minus 4 times the a was 1 and the c was negative 35. And that's all going to be divided by 2 times 1. And so now I can work on simplifying this to find my values for x. X equals 2 plus or minus the square root of negative 2 squared is 4. And then negative 4 times 1 times negative 35 is a positive 140. That's going to be divided by 2 times 1, which is 2. So x is going to equal 2 plus or minus the square root of 144 divided by 2. Now the square root of 144 is 12, so x equals 2 plus or minus 12 divided by 2. And now I can kind of take the two different paths for the plus or minus. X could equal 2 plus 12 divided by 2, or x could equal 2 minus 12 divided by 2. So x could equal 14 divided by 2, which means x could equal 7. Or x could equal 2 minus 12, which is negative 10, divided by 2, which results in negative 5. And those are my two possible solutions, 7 and negative 5. So when solving an equation using a quadratic formula, first, get your equation into standard form, define your a, b, and c, and then make your substitutions into the formula and carefully solve to get your solutions. Next, solve the equation using the quadratic formula round to the nearest tenth if necessary. Well, let's set up what is my a. It is 2. My b is negative 2. And my c is negative 5. So when I have the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. X is going to equal the opposite of negative 2. Here is just a positive 2, or the negative of negative 2 is positive 2, so we'll just write it as a positive 2, plus or minus the square root of negative 2 squared minus 4 times 2 for a, negative 5 for c, all divided by 2 times 2. Well, as we continue solving this now, x is going to equal 2 plus or minus the square root of negative 2 squared is 4. Then the minus 4 times 2 times 5 is plus 40. That's again now going to be divided by 4. So x equals 2 plus or minus the square root of 44 divided by 4. And now I can go on my two little paths here. I could solve, say, x is going to be 2 plus the square root of 44 divided by 4. And also x could equal 2 minus the square root of 44 divided by 4. Now the square root of 44 is about 6.633, so this will be 2 plus about 6.633 divided by 4, while this one would be x is 2 minus 6.633 all divided by 4. And when you add and divide and then round these to the nearest tenths, you'll get about 2 2/10 and about negative 1 2/10. And those are our solutions for this equation. In example 2b, solve the equation using the quadratic formula round to the nearest tenth if necessary. This equation is not yet in standard form, and so we need to subtract that 4 from both sides. So we'll have 5x squared minus 8x minus 4 equals 0 is our equation in standard form. And my a is going to be equal to 5, my b to negative 8, my c to negative 4. So when I have x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a, I can now substitute in my numbers. X is going to equal the negative of negative 8 is 8 plus or minus the square root of negative 8 squared minus 4 times 5 times negative 4 all divided by 2 times 5. And as we continue solving, x equals 8 plus or minus the square root of negative 8 squared is 64. And then 4 times 5 times 4, but including our two negatives there, is going to result in a positive 80. And that's going to be divided by 2 times 5, which is 10. Well, now we have x equals 8 plus or minus the square root of 144 divided by 10. And now the square root of 144 is actually just 12. So I'll have x equals 8 plus or minus 12 divided by 10. And now we have our two different paths. X equals 8 plus 12 divided by 10, or x equals 8 minus 12 divided by 10. In the first one, we'll have x equals 20 divided by 10, which is just 2. In the second one, we'll have x equals negative 4 divided by 10, which is, well, negative 4/10. And those are my two solutions for this quadratic equation. Here in our concept summary, you can tell that we've used a bunch of different methods to solve quadratic equations. We've used the factoring, we've used graphing, using square roots, completing the square, and now in this lesson, the quadratic formula. And they all have good times to use. For example, graphing we can use when an approximate solution is sufficient. And now for the quadratic formula, it can be used for any equation as long as it's ax squared plus bx plus c equals 0. And so now we'll solve this example in a bunch of different ways. We'll solve by graphing, factoring, completing the square, and using the quadratic formula. Well, to solve this equation by graphing, we do need to work to get this into standard form first, which would be 3x squared minus 5x minus 12 equals 0. And we'll first look for now our axis of symmetry. So x is going to equal negative b over 2a. So x is going to equal 5 over 3 times 2. So x equals 5/6. So we can draw our axis of symmetry in here for 5/6. And now we can look for our vertex. We'll put 5/6 back into this equation, so 3 times 5/6 squared minus 5 times 5/6 minus 12 needs to equal 0. When I simplify this, I get my vertex, or at least this y, to equal negative 14.08. So my vertex is going to be at 5/6 and negative 14.08. So if I count down by 2's, negative 2, 4, 6, 8, 10, 12, 14, my vertex will be right around here. My y-intercept, that's at negative 12. So that's right here. And now my next point will be somewhere right around here using the axis of symmetry. And now we get to kind of guess for the other points. We know we're going to be up here somewhere. And so I'm just going to guess, let's do a random x. What if x equals 3? Well, if we put 3 in for x, just a random guess again, we get 27 minus 15 minus 12, which, is 0. Shocking. So that one of our points is going to be at 3, 0, which is right here. And that is actually then one of my solutions for this equation, since it is one of the x-intercepts. Now, to find our matching side using the axis of symmetry, we're just a little bit away here, so we need to go the equal distance on the other side. And actually, this is going to be right around here, which, as it turns out, is negative 4/3. So my solution is 3 and negative 4/3. Now to solve this equation by factoring, we once again need to get this into standard form. So if we subtract the 12 from both sides, we have 3x squared minus 5x minus 12 equals 0. And now, if we look at our perfect square trinomial, it's not that. It's not the difference of squares, so we can use our good old ABC method here. A is 3, B is negative 5, C is negative 12, and so we're going to be looking for a product of A and C. That's negative 36. That adds up to negative 5. Well, that would result with negative 9 times 4, and that adds up to negative 5. And so this can break apart now into 3x squared, and the negative 5x is now broken into minus 9x plus 4x minus 12 equals 0. And now I can factor by grouping. I can group my 3x squared minus 9x with then the 4x minus 12 in a group. In the first grouping, I can pull out a 3x, which leaves me with x minus 3. In my next grouping, I can just pull out a 4, which leaves me with x minus 3. And now if I rearrange, we're left with 3x plus 4 times x minus 3 equals 0. And now using the zero product property, I can say 3x plus 4 might equal 0, or x minus 3 could equal 0. In my first equation, subtract 4 from both sides. 3x equals negative 4. Divide by 3 on both sides, and x is going to equal negative 4/3. It's one solution. The other solution, add 3 to both sides, and x equals 3. And it's really good that we have the same solution as the graphing, since we, well, should. Now what about completing the square? 3x squared minus 5x equals 12, same equation, but now we need to get rid of this 3 first. So if we divide by 3 on both sides, we're left with x squared minus 5/3 x equals 4. And now I need to, well, complete the square, if you will. I need to take my 5/3 here. I need to divide it by 2, and I need to square it. Remembering some of our fundamentals of fraction division here, this would be 5/3 divided by 2/1 squared, which is 5/3 times 1/2 squared, which is really then just 5/6 squared, which simplifies into 25/36. So that's what I'm adding to both sides now, 25/36. And so now we have x squared minus 5/3 x plus 25/36 equals 4 and 25/36. On this left side, I do have a perfect square trinomial, so I can rewrite this then as x minus 5/6 squared equals 4 and 25/36. When I go to take the square root of both sides, well, before I do that, let's rewrite this 4 and 25/36 as an improper fraction. That improper fraction is 169/36. So now when I take the square root of both sides, I'm left with x minus 5/6 equals, and the neat thing about taking the square root of fractions is you can take the square root of the top and the square root of the bottom. So this is going to be plus or minus 13/6. It's kind of incredible how this works out, because now when I add the 5/6 to both sides, we'll have x equals 5/6 plus or minus 13/6. Well, my two little different paths here, 5/6 plus 13/6, or x is 5/6 minus 13/6. My first path results in 18/6, which is 3, or my second path results in negative 8/6, which simplifies down to negative 4/3. So same answer as the previous two, just a different method. And now we have our quadratic formula in today's lesson. Well, let's rewrite this once again in standard form. 3x squared minus 5x minus 12 equals 0. My a equals 3, my b equals negative 5, and my c equals negative 12. And for the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And now we substitute in. The negative of negative 5 is positive 5, plus or minus the square root of negative 5 squared minus 4 times 3 times negative 12, all over 2 times 3. So x is going to equal 5 plus or minus the square root of 25 plus 144, all divided by 6. So x is going to equal 5 plus or minus the square root of 169, all divided by 6. Now the square root of 169 is 13, so I can rewrite this as 5 plus or minus 13 divided by 6. And now we get to have our two different paths. X equals 5 plus 13 divided by 6, or x equals 5 minus 13 divided by 6. And we've seen how this story's played out a couple times now. X is going to equal 3, or x is going to equal a negative 4/3. So we have graphing, factoring, completing the square, quadratic formula, a bunch of different ways to solve quadratic equations. What is the discriminant? Well, in the quadratic formula, the expression under the radical sign, which is our b squared minus 4ac, that is the discriminant. And it can be used to determine the number of real solutions of a quadratic equation. So if b squared minus 4ac cranks out a negative number, there will be no x-intercepts, which means there's no real solutions. If it equals 0, that means, well, it is going to be on the x-intercept and one real solution. If it's a positive solution, there'll be two x-intercepts and two real solutions. So state the value of the discriminant for the equation, then determine the number of real solutions of the equation. Well, let's get this into standard form first. 3x squared plus 10x, subtract that 12, equals 0. So my a equals 3, my b equals 10, my c equals negative 12. And my discriminant portion, that's all we need to worry about here, not the entire quadratic formula, just the discriminant. b squared minus 4ac. So we'll put in 10 for b, minus 4 times a is 3, c is negative 12. So 10 squared is 100. And then negative 4 times 3 times negative 12 is 144. And this simplifies into 244. And so it's a positive discriminant, so we can say this has two real solutions. And lastly, state the value of the discriminant for this equation, then determine the number of real solutions. Well, it's in standard form, so my A is equal to 1, my B is equal to 2, my C is equal to 2 as well. And again, just the discriminant portion is B squared minus 4AC. My B is 2, so 2 squared minus 4 times 1 times 2. This becomes 4 minus 8, which is negative 4. And since I have a negative discriminant, that means I'm going to have no real solutions. And that's all we need to say, no real solutions. And that is it for this lesson on solving quadratic equations by using the quadratic formula, as well as a summary of all of our different solving quadratic equations methods and the discriminant. Good luck.